Okay, guys, you ready? Here we go. Let's go ahead and do this problem. There's something similar to this on the test. And this problem says, hey, look at this function. Tell me, is this function continuous everywhere, or is there discontinuity? And if there's a discontinuity, tell me why this thing is discontinuous. Does that make sense? Okay, so what do you guys think I should do first? Plug in, okay? Well, it's not a limit problem, so it's not plug in. Factor, okay, so I'm going to go ahead and factor this. So this will be f of x equals x minus 7, no, x plus 7, right? X minus 1 over. Guys, how do I factor this bottom part? Just take out an x, so x minus 1. Anything good happening here that you see? What? There's a hole. Guys, if I have a hole in my picture, is this picture continuous? No, so I already know that the answer is discontinuous. You guys good with that? Okay, so I'm going to put discontinuous. Now, if I say that a function is discontinuous, I have to say two things. One is why it's discontinuous, and at what point it's discontinuous at. Okay? And hopefully the definition of continuity will help me. Okay? And remember, a function is continuous at x equals c if three things are true. Do you remember those three things? F of c must exist. What's the second thing? The limit at c must exist. And what's the third thing? F of c must be equal to the limit at x of c. All right, so there it is. So remember the definition of a friend. If any one of these is not true, then I can say this function is discontinuous. All right? And what did you tell me that happens right here? What does this tell you here? X minus 1. There's a hole. Guys, where is the hole at? X equals 1. Do you see how to get 1? Had this been x plus 1, where would the hole have been? Negative 1. All right. Guys, if the hole is at 1, you know what? Just for fun, tell me what the y value of the hole would be. The y value. There's a hole at 1, so this cancels out. What's the y value? 8. So you would put 1 over that wherever there's an x, and it'd be 8 over 1. You guys see that? And that's how you get the y value. Okay. So I'm not sure if you need to know that for your test, but that's pretty fun to know. All right, guys. If there is a hole, is that a discontinuity?
Yes.
Yes. Which means one of these things, or maybe more, doesn't apply. Which one doesn't apply? F of c doesn't exist, right? So guys, what you would write for this question is you'd write f. Oops, make sure you copy the though. So you'd write f of 1, d and e. You would box this in. Make sure you did say that this thing is discontinuous. And do you see your answer? That's pretty much it. Everything boxed in is what I'm looking for. Any questions about that? Okay, it's not. You don't even have to tell me that there's a hole, actually. If you tell me that this doesn't exist and you're right, then I'm good with that. Grant?
So are we keeping our warm-ups with us today?
Yes, if you want to, you can. Oh, did we finish warm-ups yet? No, we're still on warm-ups. Yeah. I'll give you the option to keep it if you want. Okay. So guys, that is an answer, and I would be happy with that. You can stop right there. But guys, there are some other answers to this problem. You agree? Where else is this function discontinuous? At x equals 0. How'd you get that?
Because it's just x equals 0.
Right, because, are you guys good on that table? Just want to make sure you're doing calculus. Okay, guys, because to find DAs, you remove the whole bottom 0. And a vertical asymptote is a discontinuity. Do you agree? Because if you had a vertical asymptote in your function would be discontinuous there. So guys, where is the DA in this problem? Right here. The bottom is x equals 0, so that is a vertical asymptote, okay? If that is a vertical asymptote, it is a discontinuity, okay? Now, I can't just say there's a vertical asymptote. I got to say, which one of these doesn't apply? Which one doesn't apply, guys? Let me just draw a vertical asymptote. Where is it at? At 0? A vertical asymptote at 0. And I actually don't know what this picture looks like, so I'm just going to make it up. Maybe it's something like that. Okay? If it's something like that, guys, what doesn't apply here? Is there a function here at vertical asymptotes? Is there a y value? No. So a great answer would be f of 0, what? D and e. That would be a great answer. Okay, what's another great answer? Is there a limit at vertical asymptotes? What three places are there no limits? Jump,
Crazy
crazy oscillation, and infinite discontinuity, or vertical asymptote, right? So this would, you could also say the limit as x goes to 0 of f of x d and e, and that would also be a great answer, okay? Guys, are there limits at hold? Yes, there are limits at hold. So guys, up here, okay, I just want to tell you the number 2 wrong answer up here would be students will write the limit as x goes to 1 of f of x d and e. They would write that. Is that true? No, there actually is a limit at x equals 1. So if you write that, okay, I would write bad things on your test. Not only will I take off points, but you will get a long comment from me, okay? So make sure you understand there are no limits. There are limits at holds, okay? All right, so let me just make sure you guys understand this. For this problem, you would want to write discontinuous, you would want to write this one, or this one, or this one, and they would all be counted right. Is everybody good with that? Either or. This one, or this one. Make sure you tell me it is discontinuous. There's also something else you could write here, though. You could also write at x equals 1, because you have a hole, you could write that f of 1 is not equal to the limit as x goes to 1 of f of x. Why? Because this right here doesn't exist, right? And this right here exists, right? So, of course, something that doesn't exist is not equal to something that exists, okay? So you could write this. To me, it's a little awkward, but there's nothing wrong with it. But if had you written this, I would have been okay with it also, okay? But guys, make sure you understand. Do you see that both of these things are d and e, okay? That does not mean that f of 0 is equal to the limit as x goes to 0 of f of x. I mean, I know this is d and e, and I know this is d and e, but you cannot set two d and e things equal. Does that make sense? I don't know if that makes any sense to you. You know what I'm saying? I mean, it's like saying there's no such things as ghosts and there are no such things as unicorns. So therefore, ghosts are equal to unicorns because there's no such thing as both of them. Does that make sense? Okay. So, so these are not equal. Okay. Any questions about that? All right. Can you do this on your test? Okay. Good luck. I think you can do it also. Go ahead and pass up your warm-ups if you'd like to not keep it at this time. If you'd like to keep it though, feel free to keep it and then you'll turn it on Monday. Okay. If you turn it, I'll probably get a grade for it. So I do need a grade for these warm-ups, but I'll get it on Monday. But if you don't need it, then go ahead and pass it up. Then you don't have to worry about trying to find it.
Can I take a picture of it?
Yeah, you can take a picture of it. It's fine. Okay. So guys, let's look at this problem up here. Okay. If on a test I said, hey, look at this piecewise function and tell me what value of k would make this continuous. Can you do it? Where's your breakpoint on this problem?
0.
Okay, so I'm going to put in my breakpoint. Okay, if I look at this problem carefully, it says anytime that x is not equal to 0, I have this function going on, tangent x over 3x. Where on my axis is x not equal to 0? Everywhere. Do you agree? Except for 0. Okay, so over here, this value of the function, the y value is going to be tan x over 3x. Over here, it will be tan x over 3x. Only, and it's probably, oh, that's a big hole, but only right here would probably be, the problem child. And think about it, if I plugged in 0 here, right, it wouldn't work. You get 0 over 0. Okay, so something weird is going on at 0 on this problem. Okay, the other thing I know, that when x is equal to 0, though, I have what value? K. So I know that when x is equal to 0, that value is k. Now the question is, what does k need to be so that this thing is continuous? The way I drew it, is it continuous? No. So what does it need? What needs to happen? Right? It needs to go inside there. So what happens is, if k were equal to the limit coming from both sides, then this would be continuous. Does that make sense? So the way you would set up this problem is you would say, if the limit coming from both sides of that tangent x over 3x, okay, is equal to what y value? K, then you would have a continuous function. Okay, so I'm going to set that up exactly like that. So this will be the limit as x goes to 0 of tangent x over 3x must be equal to k, and that will be, and whatever k is, that will be my answer for k. All right, so let's go ahead and solve this. If I just look at the left side, do you see you get 0 over 0? Yes. What do you say?
Oh,
gotta do something else. Factorable? conjugate pairs?
No.
Common denominator, do I have a fraction and a fraction? Okay, how about just simplifying and multiplying out, getting rid of all the parentheses? Okay, no parentheses here, it's not going to help. Okay, good guess though. The answer is either yes or no. Okay, so guys, what other thing can I do here? Tan x is really sine x over cosine x. So I'm going to rewrite this to sine x over cosine x times 1 over 3x, okay? Make sure you understand, dividing fractions easy as pie, flip the second and multiply. So this is equal to k. Anything good happen here? See it?
You get
Sine x over
3x.
yeah, I don't want the 3x though. What do I want? Just the x. So I've actually got something good here. I've got the sine x over x. And if I know limit properties, then this is equal to sine x over x times the limit as x goes to 0 of 1 over 3 cosine x equals k. You guys following so far? Okay. Well, something really nice happens because I know what this is. I've memorized it. What is that? 1 times the limit as x goes to 0. Well, let's just plug it in. If I plug in 0 here, what do I get? Let me get 0 in red. Oh, that's not red. Okay, what's cosine of 0, guys? 1. So do you see that's 1/3? Okay, so what's your k equal to? Okay, and you can test it. You know, put k as 1/3, put it in here. Okay, graph it on your calculator and see if you get the same thing. Okay, any questions on this problem? Okay, so make sure you're good with that.
Doesn't tangent always go through the origin? So at 0, why isn't it just 0? Why is it
Because
0?
because you have this 3x, so you can't have 0 on the denominator. This thing, 0 not allowed. Does that make sense in
I
denominator?
mean, I know that, but...
Oh. Talk to me later.
Okay.
You and Brant both talk to me later. No, just kidding. Just if you're still not understanding, I'll spend some more time with you. Okay, let's go on to homework questions. So guys, questions on your homework. What questions do you have?
8.
Or quiz? Oh, we haven't done our quiz yet. Questions on your homework first.
8.
8. Okay. So number 8. If I remember correctly, number 8 is a limit as x goes to 0 of x over 1 minus cosine x. Is that right? Or is it x squared?
X squared.
Is it x squared? Is that right? Number 8. I think it's the IVT worksheet. IVT.
Yeah, that's right.
Okay. Wait, is this the one you want? I want to make sure I'm doing the right one. Okay. All right, guys. If you look at this, you might be tempted to do this. Okay, and you would be right. Okay. The only problem is you know the limit as x goes to 0 of 1 minus cosine x over x. You've memorized that? What's the answer? 0. But remember what I told you? You can't flip this. Okay? I mean, you can flip it, but what's the flip of 0? Yeah, it's DNE. It's 1 over 0, or some number over 0, right? And so actually, it won't get you anywhere, because this will give you 1 over 0. When you plug in 0 for your x, that'll give you 0. I mean, you still get 0 over 0. Does that make sense? It doesn't really get you anywhere. So what you have to do for this problem, and when I do it, you guys are going to be like, wait, how did you know that? Well, guys, you guys know it too, all right? You can always trick the problem and do conjugate pairs, okay? And somewhere in life, you're going to have to be like saying, let me try a conjugate pair on that. Somewhere in your math life, okay, you're going to have to be able to, you know what, that looks like something I could do conjugate pairs on. Somewhere in your life, you're going to have to be like, you know what, that looks like a Pythagorean identity, okay? Those are things that if you continue with math, you just are expected to know. And if you do something like this, and I can't say that when I did this the first time, I knew that it would work out. But what I did know is I was allowed to try it, okay? And if you see that this is a minus b and this is a plus b, what do you know about this down here? A squared minus b squared. Well, what's a squared minus b squared here? 1 minus cosine squared x. And guys, this should look really familiar to you because you know that the cost of sin is $1, which means that sine squared x is equal to what? 1 minus cosine squared x. So this whole bottom here is really just sine squared x, okay? And again, guys, I know some of you guys are like, hey, how did you know that? No, you knew that too, okay? You did. All right, so guys, this actually simplifies to x times x over 1 plus cosine x sine x times, right? Do you see anything beautiful here? Sine x over x, or x over sine x, right? This right here, well, the limit of this is equal to what? 1, okay? The limit of this is equal to 1. For sure, guys, if I took the limit out, that is not equal to 1, okay? But the limit as x goes to 0 is definitely equal to 1. So what happens here is I have 1 times the limit as x goes to 0 of 1 plus cosine x. And what is the answer to that? 2. The answer is actually 1 plus 1, which is 2. Okay? What other questions do you guys have? Number 7. Is that the one right before? Okay. So that's the limit as x goes to 0. We're looking at number 7, guys. Is it sine 4x? I don't remember.
3 sine 4x.
3 sine 4x over cosine 3x?
Sine 3x.
Oh, sorry. Sine 3x. Anything else? You're good? Okay. So, yeah. Sine 4x, guys, do you agree that I want a 4x on the bottom? Right? Well, guys, if I want a 4x on the bottom, let me just put a 4x on the bottom. What do I want on the top?
4x.
No, not 4x. 3x. You agree with that? Well, I already have a 3. Why don't I just put in an x? You guys good with that? But check this out, guys. If I multiply by 4x on the top, what do I have to multiply on the... I'm sorry, if I multiply by 4x on the bottom, what do I have to multiply on the top? So do you agree that what I did not change the value of my function? I multiplied by 4x on the top, and I multiplied by 4x on the bottom. You agree with that? Now look what's going to happen here. Okay? This sine 3x can match with what? Okay, this sine 4x can match with what? There you go. Look at all this discovery that's going on. Okay, so guys, this is going to be equal to 4 times 1 times 1. You see it? And that's going to be 4. Okay? All right, what other questions do you guys have? You good? Okay, let's look at your quiz, guys. I'd like you to trade papers with a friend, and we're going to grade them together. Okay, guys, get out a different color pen or pencil. This is a real grade. I want you to sign your name at the bottom. Don't sign your name, actually. Write your name so I can read it. At the bottom right of the paper if you're grading that paper. All right, you guys ready? So what I want you to do, guys, is write down the right answer. Write down the right answer. I don't care if you put an X or not. I don't usually put X's when I grade. But write down the right answer so they can know that it's wrong, okay? 1A, -2. 1B, 1. 1C, D and E. 1D is -2. 1E is 2. 1F is -2. Number 2, the answer should be E squared. Number 3, the answer should be 2/7. 4, the answer is 0. 5, the answer is 1/6. 6, the answer is -1/9. 7, the answer is infinity or D and E, either or. Number 8, the answer is -1. And so, guys, if they have +1, it's completely wrong. Okay, I'll go back and put partial credit. You guys don't do that. Just tell me, just write the right answer next to it. Number 9, the answer should be 81, 1/9, and 15. Number 10, the answer should be 0, square root of 3, and -square root of 2/2. Okay, guys, you put a grade on it. So number 1, each part is worth 4 points. Number 2 through 8, each part is worth 8 points. Again, guys, I'm going to go back and put partial credit. You guys fill this in. Subtract the points. And then number 9, each part is worth 4 points. And number 10, each part is worth 2 points. Okay? So calculate that, put the grade on the top. I'm going to let you guys take this home, but I'm going to look at it on Monday. Okay? Yeah, Brandon.
Can you repeat the...
Which numbers? All of them? So number 1, every part is worth 4 points. Number 2 through 8, every part is worth 8 points. number 9, every part is worth 4 points, and number 10, every part is worth 2 points. Okay, yeah.
For 10C, what if we wrote an equivalent value but not negative root 2 over 2?
Oh, like you were in decimate?
No, I wrote negative root 1/2.
Oh, that's fine. Yeah, equivalent value is totally fine. Guys, for example, a number 2, the answer is e squared, but if you wrote like the decimal, that's fine only if you went how many decimal places? 3 decimal places. If you did not go 3 decimal places, then it's a -1. Okay? But guys, get in the practice of going to 3 decimal places. All right, pass it back to the owners. Take a look at what you did wrong or right, and ask your questions.
I bet everybody.
You guys good?
Wow.
All right, so you guys are going to turn that in on Monday. If you don't need to keep it, go ahead and turn it in today. I'm fine with that. Okay, so you can turn it in today if you want to grade right away. Otherwise, turn it in on Monday. Okay. All right, let's look at our new unit. You guys ready? Hopefully you guys picked up a worksheet up here, and we're looking at the definition of a derivative. Today's the first day we'll be talking about derivatives. We're going to define what a derivative is, okay? So I want you guys to look up at this line here, and tell me what you see when you look at this thing. Tell me a slope. What's the slope here? What's the slope? Do you agree it's y minus y over x minus x? Do you guys agree the slope can never be y over x? Is everybody good with that? A slope always must be a difference quotient. So guys, if you ever see this word difference quotient, what they're asking you for is the slope. So that's a vocabulary word that you need to know, difference quotient. Another vocabulary word that you need to know is average rate of change, okay? Do you feel comfortable that those two words here are synonyms for the word slope? Okay, so make sure you understand that. And you guys see this black picture here, we call it a line, but what if I told you this isn't really a line? Would you believe me? That this curve is not really a line.
That's crazy. I wouldn't believe.
Yeah, you wouldn't. But watch, it really isn't, because the way I got this picture was I just took a part of a sine curve, okay? And what I did was I got part of a sine curve, okay, and I zeroed in on x equals 0. And I got closer and closer and closer. Does that sound like a limit to you? And
Yes.
closer and closer until I got so close. You guys can't see because you're way over there. I got so close that this part right here, I know you can't see because you're way over there, but if you could see what I could see, that right there is a line. Okay? And that's what I drew on the other picture. And it doesn't have to be at x equals 0. It could be, this point over here. Okay? If I wanted to figure out what that looks like when I zero in on it, all I do is get closer and closer and closer and closer until, just believe me, it looks like a line, okay? And the slope of that line is called the derivative, okay? The slope of that line is the derivative. So over here, okay, if I got that line, and I'm going to blow up the line so you guys can see it, because with your naked eye, you can't see it. Okay, but if I drew a line there, if you could find the slope of this line, it would be the derivative it'd actually be the derivative of sine x, okay, at x equals 0. And that's the notation. But that would be the slope of this line. And if I went over here and I took that line and I extended it so you guys could see, I magnified that line so you could see it, the slope of that line, okay, the value of that slope would be the derivative right there. What do you know about the slope of this line here? Would be negative. What do you know about the slope of this line here? Positive. So you know the derivative here is positive. You know the derivative here is negative. So that's your introduction to the derivative. So now I'm going to formally define what a derivative is. Okay, so let me show you. Draw a picture for you so you understand it. But all you need to do is on the top of your paper, it says, the formula for the derivative on the very top. You see the formal definition of a derivative in the alternate form. You have to memorize these two formulas. So I'm going to derive them for you up here, and then you'll just memorize them. Okay, you write them down, you'll memorize them. So let me tell you what a derivative is. What a derivative is, if I wanted to find, okay, so let me call this x. If I wanted to find the slope of the tangent line right here, do you agree? If I drew a line right there, remember I'm zeroing in until I'm really, really close, and I magnified it for you. If I got the slope of that, that would be the derivative, okay? So what I'm going to do is, if this is x, okay, and green is my curve, if this is x, do you agree that this is f of x?
Yes.
If I moved over a delta x, okay, distance, do you agree that this would be x plus delta x? And if I know that that's x plus delta x, if I come up here, I find this point here, and I move over here, what would be this y value here? F of x plus delta x. You agree with that? And if I wanted the slope of a secant line, so let me clarify what a secant line is. The secant line, if you remember in geometry, is if you put 2 points on your curve, and you connected them together. Okay, mine's a little squiggly because I'm nervous, okay? But it should just be a straight line if that's a secant line. If I wanted the slope of that secant line, that would be, so let me write it, the slope of the secant line, that would be equal to, see if this makes sense, y minus y, so y minus y, right, over x, this x, minus this x, right? That's the slope of the secant line. You agree with that? But I don't really want the slope of the secant line. I want the slope of the tangent line right here, okay? The slope of the tangent line is really the same thing as the definition of the derivative. So what I want is I want the slope of this line, okay? So it's actually a limit problem. What I'm going to do is I'm going to take delta x, I'm going to make it what? Smaller and smaller and smaller. So it turns out that the derivative, and there's another notation for derivative, if you do f prime of x, is equal to the slope of the tangent line, which is be equal to the limit as delta x goes to 0 of this slope. So I just copy the same formula, x plus delta x minus f of x over x, This right here, do you see these cancel out here? Right, x minus x. So on the bottom, really, all you have is delta x, okay? And so this is the formula that you memorize, except that for some reason, a lot of mathematicians, you'll see this sometimes, but a lot of mathematicians will call your delta x h, okay? And so the formula you need to write at the top of your paper is the definition of a derivative. The formal definition is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, that's a formula you're going to memorize. It looks very intimidating right now, but after you do about 40 problems, you'll have it memorized. Okay, so you're going to write that down on your left top of your paper. That's a formula you have to have memorized. And you'll have a formula quiz sometime soon, and you'll have to spit that out for me. Okay, that's called the formal definition of a derivative. We can also do what's called the alternate definition of a derivative. And the reasoning is very similar, but the alternate definition of a derivative is instead of finding the derivative of x, I'm going to find the derivative at some number, at some point c. So this would be 5 or 3 or negative 2 or something like that. And so I want the derivative right there. So this f here, this y value now is no longer f of x, but I want to find the derivative at c. So this is f of c. Instead of going over delta x, I'm just going to call this x here. And so this up here now is going to be called f of x. Do you guys see? I mean, the reasoning is going to be the same. There's just some labeling of these things something different, okay? So the slope of the secant line here, now, if it makes any sense to you, so the slope of the secant line is going to be equal to f of x minus f of c, right? Y minus y over what? X minus c, okay? But I don't want the slope of the secant line. I want the slope of the tangent line. So that just means x approaches c. Does that make sense? So now the slope of the tangent line, which is the same thing as the alternate definition of a derivative at some point c, is the limit as x approaches c of this formula. And this formula, guys, write it on the top right of your paper, okay? And this is a formula you need to know for the alternate definition of a derivative, which is almost the same, okay, as the formal definition of the derivative. Okay, so you need to know those two formulas. Okay, let me show you how to apply them. What time do you guys get out of this class? I have no idea. 28, is that right? Okay, so guys, let's go to an example problem, and this will be how you do numbers 1 through 3 on your assignment. I'll put a few solutions up to get you guys going. Okay, if you look at this, if I tell you, this is kind of a pre-assessment. if I tell you this is f of x, if I said what's f of 1, what would you do to find f of 1?
Plug it in.
Plug everywhere there's an x, right? You agree with that? Okay, what if I said find f of a, though, not f of 1? Then everywhere there's an x, you would put a. Okay, that's pretty easy. Okay, what if I said, no, this time find x plus h, f of x plus h, what would you do?
X plus h squared plus 2x equals h minus 3.
You agree? Okay, so all it means is everywhere there's an x, you're going to plug in x plus h, all right? So if we look at the formal definition of a derivative, so let me get a hard problem. Okay, it's not really hard, but if we get the formal definition of a derivative, and I want to find what the derivative of f of x equals 3x squared plus 2x minus 5 is, what I would do is first I would write the formal definition of a derivative. So let me just write it for you. And you guys should be able to eventually write this from scratch too. Okay? So all I'm going to do is plug into this formula. So that means the derivative is equal to the limit as h goes to 0. And what is this? It says that everywhere there's an x, I put in what? X plus h. So here's my x right here. I have an x here and an x here. So this is equal to 3x plus h squared plus 2x plus h minus 5. Do you agree? Okay? And then this says here, I subtract something. What do I subtract? F of x. So what is f of x? This whole thing. Guys, make sure, though, you put the parentheses. Okay, if you don't put the parentheses, then all you'll be doing is you'll be subtracting the 3x squared, and that's not really what you want. Okay, this is all over h. Okay, and if you wanted the derivative of this function, 3x squared plus 2x minus 5, what you would do is solve this limit. Everybody good with that? And we've done these limits before. Okay, if you plug in your h, trust me, you're going to get 0 over 0. Okay, and what you're going to do here is you're going to multiply out and simplify. So what you get is the derivative is equal to the limit as h goes to 0 of 3x squared plus 2xh plus h squared. Okay, all I did was FOIL that. Okay, plus, then I'm going to distribute this 2, so that'll be plus 2x plus 2h, and then I'll carry down the minus 5. Then I'm going to distribute this negative. All you're doing is try and get rid of all your parentheses. So that's going to be negative 3x squared minus 2x plus 5 all over h. And guys, I know it's really ugly, but guys, people have ugly babies and they still keep them. Okay? So we're going to keep going. Okay, just hang on. All right. Now, this 3 can still be distributed a little bit further. Okay, so this will be, did I just record that? I might have to. Okay, here we go. This is going to be 3x squared plus 6xh plus 3h squared. You guys agree with that? Plus 2x plus 2h minus 5 minus 3x squared minus 2x plus 5 all over h. Okay, now this looks very difficult until you notice that some things cancel out. Do you notice anything that cancels out? Yeah, the 3x cancels out, the 5 cancels out, and there's one more thing that cancels out. The 2x cancels out. So this really just becomes the limit as h goes to 0 of 6xh plus 3h squared plus 2h over h. If I can solve this problem, I can find the derivative to f of x. Okay? If you plug in here, do you see that you get 0 over 0? Because everywhere there's an h, you're going to put in 0. Yes. Right? What can I do? What's the first something I can do? Factor out the h, right? So if I factor out the h, what you'll get is h times 6x plus 3h plus 2 over h. And I just want to point out that if you plug in h equals 0, what do you get? X plus 2. Okay? I'll have this online, guys, and some examples from all these other problems. They'll help you guys do your homework. All right? But that is the derivative to the original function that we have. All right. Guys, good luck on studying for the test tonight. Okay? Ask me questions online if you need to, and I'll try to answer as soon as I get your questions. All right? Have a great day, guys.
Just complaining to you.